Hello students, welcome you all for the second class of machines. What did we see in the last class? We have studied in the last class regarding the introduction to the machines chapter, and also we have seen functions and uses of machines. What are the functions? It is used as a force multiplier, it is used as a speed multiplier, and the machine is also used to change the what you mean by apply of effort at a convenient point, and also machine is used to change the direction of effort. There are four functions and those uses by the machine. So how do we define the machine? Machine is being defined as machine is used to know that it is used as a force multiplier, as a speed multiplier, changing effort of a convenient direction and change the direction of effort. All those including forms and what you mean by machine. Machine is a device. We need to write that machine is a device. So I have told you that in part A there is technical terms which has been left out. There is even levers that has been removed from your syllabus. So let us know the technical terms. Technical terms in the sense we use in the language of engineering. In the engineering language how we use the thing we are doing. So first one, what we mean by load. However, we have used load and effort in the last class itself. What do we mean by load? What do we mean by effort? Let us see. Load. What do you mean by load? A resistive or opposing force. A resistive or opposing force to be overcome by a machine is called load. Means you have a huge stone. Right? You already know to move this huge stone through hands is very much tough. So which device you will use? You will use a device called as what we mean by crowbar. What do you mean by crowbar? Now you are being applying here your force on crowbar in order to move this. No doubt it is going to act as what you mean by force multiplier. I have already told you. It is used as force multiplier. But whatever the resistive force oppose this, when you are moving the stone, it automatically moves. No, what it will does, it will oppose a force on the machine. That is what a resistive or opposing force to be overcome by the machine. Now, what machine will do? Even though if this is applying a resistive force, it will overcome it. Right? See, the resistive or opposing force to be overcome by a machine is called as a load. Keep this, you have to keep in mind. Load is always applied by the things which we are moving or a body which we are moving. Understand? But this, whatever the resistive force, see, load is also a force, effort is also a force. But effort is the force applied by us. Load is the force applied by the resistive force. Resistive force is an opposite force applied by the object. Effort is the force applied by us. Now, who is the mediator? Mediator is the machine. Understand? How you are applying, it will act according to that. Now, you are applying a less force, less effort. Means you are applying less effort. Will the stone move? No. You need to apply some force in order to move this stone. That we all know that. If one member cannot do that, what we have to do? Two members should do that by using two crowbars. Understand? This is what my load. Here, understand the concept of load. Load means resistive force applied by the object. Right? Resistive or opposing force to be overcome by the machine. It should be overcome by the machine. This is applying that. Object is applying the resistive force. This is what we mean by load. Understand? Load, it is also denoted with the letter L. Understand this? As class prolongs, you will understand better and better. Now, effort. You know effort. The force applied on the machine to overcome the load. Very beautiful. Now, let me take this example again. You are applying some force on what? Machine. To overcome what? To overcome load. Is called the effort. No doubt, it is also a force. It is also a force. It is a direct force. It is a resistive or opposing force. Why? In your view. In your view. When we see in a view of stone is having effort, you are applying a load. Understand? In your view, you are applying a effort force. Force is effort. Because we are trying to move, so it is our effort. Right? Load is the resistance. passive force applied by an object. So we are applying effort on the machine, even load is being applied on the machine. Finally, moving, we are strong. It depends on if your effort is more, this will act as a force multiplier and will be strong. Understand? If your effort is less and load is more, you cannot do it. Understand? See how beautiful the physics. See, it is learning of whatever we are having already. Right? See, whatever you apply is effort. Whatever stone or something, whichever object you are moving, apply is load. Here the mediator is called as what you mean by machine. Understand? A force applied on the machine. Here, resistive or opposing force should be overcome by a machine. Machine only should be the mediator between us and that, between the load and effort. This the load is called as what you mean by effort. Effort is denoted with the letter E. Remember, exactly if they ask the definition, you need to write the same. You should not go with your own words. That is very, very important for you to know. Understand? So this is what the concept of load and effort. I think you have this type of knowledge. Next, we are moving with some of the different types of terms which you have not heard before, or you might have heard few members. Okay, that is what you mean by mechanical advantage. What do you mean by mechanical advantage? Such an engineering word or something which is being used in big industries. Such terms we are using. What do you mean by mechanical advantage is the ratio of load and the effort. The ratio of the load and the effort is called the mechanical advantage. Is called the mechanical advantage. Mechanical advantage is also shortly called as the ME of the machine. Mechanical advantage of the machine. Now, how will you write it in a formula way? Remember this. See, I am writing shortly. Mechanical advantage is equals to load by effort. What you mean by load by effort? Now, one important question they will ask you in your ICSE. What is the unit of mechanical advantage? See, I have told load is also a force, effort is also a force. SI unit of force is Newton, Chancells. So, it is a ratio of two similar quantities like refractive index, what you have studied in your late chapter. Refractive index also doesn't have any unit. Why? Refractive index is nothing but N is equals to C by V. Or N on mu. We use what you mean by mu. C is the speed of rating air or vacuum. Sorry, speed of rating particular what you mean by a substance or particular state, whether it is rare, denser, glass, anything. V is always speed of light. Sorry. C is speed of light in air divided by speed of light in particular state. So always it is also ratio of two similar quantities. So refractive index also doesn't have any unit. Same way, mechanical advantage is having same. It's a ratio of two similar quantities. What is a similar quantity? Here is force. So mechanical advantage doesn't have any unit. Does not have any unit. Very important question you can ask. Okay, understand? Now we will see when mechanical advantage is greater than 1, when mechanical advantage is less than 1, when mechanical advantage is equals to 1, we will see. Now, when I can say mechanical advantage is greater than 1, okay, first condition. When mechanical advantage is greater than 1 means load is greater than the effort. Load is greater than the effort. Understand? See, load, whatever the load applied is greater than the effort, then always mechanical advantage will be greater than 1. Understand? So here the machine what you are using will act as force multiplier. Force multiplier. Very important, all these things. Remember, obviously mechanical advantage is load by effort if I am writing. When I get mechanical advantage value greater, for example, now think load is 10, effort is 9, just think. 10 divided by 9 will give me something like 0.1 point something, means 1, exactly, greater than 1. When it can be greater than 1, always when load is greater than effort, only mechanical advantage can be greater than 1. So in that case, the machine what we are using is called as force multiplier. What it is? Force multiplier. You need to remember this. Very important. Now, when you are using mechanical advantage, it is less than 1. When mechanical advantage is less than 1? When you can write it either way. When effort is more than load or load is less than effort. We will write anything you can understand. When effort is greater than the load. When the effort is greater than the load, mechanical advantage is less than 1. For example, I'll just reverse the case. 9 by 10. Here effort is more 12. Obviously it comes in 0.9 something, less than 1. When mechanical advantage is less than 1, effort is greater than the load. Only you need to remember the formula. Load by effort. That's all. Then you can know the picture. But here, load is greater than effort means machine acts as a force multiplier. Here, when effort is greater than load, it acts as speed multiplier. What it is? Speed multiplier. It is also a favorable factor. Somehow, whichever, now this acts as a speed multiplier. Very important question they will ask you from this. Okay. Next, what happens in a situation when mechanical advantage is equal to 1? When can a mechanical advantage be equal to 1? Just remember by this. When load and effort are equal, means like both are 10 and 10. What happens? Mechanical advantage is equal to. That means when mechanical advantage is equal to this, when load and effort are equal. Load and effort applied is equal. Understand? Is equal to 1. It is called as mechanical. When load and effort applied is equal, the mechanical advantage is equal to 1. Then how it can be used? It is not can be used as force multiplier also, speed also. It is used to change in the direction of effort. Change in the direction. Change in the direction. Okay, this is a change in the direction of effort. Understand? This is when we use mechanical advantage is equal to. So now we came to know this. What do you mean by mechanical advantage? The ratio of load and the effort is our load to the effort is called as mechanical advantage of the machine. Then mechanical advantage can be written in a mathematical form of L by E, that is load by effort. See, in a textbook you will be using L by E. L by E means load by effort. Since it is a ratio of similar quantities, it doesn't have any unit. Understand? Keep it this in mind, very important. Then when mechanical advantage is greater than 1, lesser than 1, equal to 1, we can see. When load is greater than effort, mechanical advantage is greater than 1. When effort is greater than load, mechanical advantage is less than 1. When load and effort is equal, then mechanical advantage is also equal to 1. When mechanical advantage is greater than 1, it acts as a force multiplier. Why it acts as a force multiplier? Just come back here. Obviously, stone is having nearly 50 kg. Just here, whatever you are applying is less than that only, that much, because you are using the machine in between. So think that the effort you are using is 25 Newton. Okay. Here, the crowbar is what the machine is doing here. It is being using. In the case, load is more, what happens? Mechanical advantage is greater than 1, then the machine acts as what? Force multiplier. But speed multiplier we cannot think of in this case. Speed multiplier can be think in the case of scissors or something like that. Understand? So mechanical advantage is one when you are changing the direction of effort. That is pulley. If you take a bucket, if you go to well and take a bucket, you are doing your work against the force of gravity. See, then it is very tough. So when your mechanical advantage will be equal to 1 is when you change the direction of effort. Understand? Your force is acting downwards, you are pulling the pulley also downwards. See, I hope you have understood. When you use a pulley, what happened? Your bucket will be coming upwards, no doubt. But you are doing the work which was downwards. You are pulling like this. If you pull up, what happens? If you could take, you all have something your own. Put a bucket and pull like this straight, you need to do a lot of work. But when you have a pulley, what happens? When you are pulling towards your effort, what you need to apply is less, or that will be equal to what? Load. Whatever the load bucket is having, the ceiling effort you will be applying, then mechanical advantage will be equal to 1. That it is changing the direction of effort. One more question they will ask. Very, very important ICSE question is, can a machine behaves as both force multiplier both as force multiplier and speed multiplier simultaneously. Very, very important question. 100%. Or sometimes they will ask. You just imagine. Can a same machine can act as both force multipliers and speed multipliers at a time? Never. Why? What is the condition for force multiplier? Mechanical advantage should be greater than 1. What is the condition for the speed multiplier? Mechanical advantage should be less than 1. How can it be acting both as force and speed multipliers simultaneously? So your answer should be no. It is not possible to act as both force multiplier and speed multiplier simultaneously, because when it should act as a force multiplier, then the load should be greater than the effort. When it should act as a speed multiplier, the effort should be greater than the load. Understand? This is the answer we need to write. So I hope I have been satisfied with you explaining the terms related to machine. This is the 3 terms I have explained now. That is what you mean by load, what you mean by effort, and what you mean by mechanical advantage. Understand? This is very, very, very important. The basics you are learning it properly. So to understand load, effort, and mechanical advantage, you should have understood the previous topics. That is introduction to machines and what are the functions and uses of machines. Unless that you won't understand this. Unless this you won't understand the next. It's been interrelated each other. And so no doubt levers are also very important. But okay, levers we will see that levers or in levers, anything you can pronounce it, but that they have been reduced from this because no doubt when we go to pulleys, we will learn all those things in that. So I hope you have understood till now. Next we will be moving with other set of terms which is related to machine, that is velocity ratio, efficiency, work done, work input, work output. Just we will see it now. Now we have our fourth technical term related to machine, that is called as what you mean by velocity ratio. Just now we have studied what you mean by mechanical advantage. So mechanical advantage is a ratio of load by effort. Remember, okay? Now velocity ratio. So how do we define the velocity ratio? Velocity ratio is the ratio of velocity of effort to the velocity of load. Understand? See, velocity of effort is written as V of E, velocity of Understand? Mechanical advantage was load by effort. But what is velocity ratio? Velocity ratio is the ratio of velocity of effort to the velocity of load. So how can we write mathematically? So velocity ratio is equals to velocity of effort by velocity of load. Understand? Even this is one type of definition of velocity ratio. Or even you know that what do you mean by velocity? From last year motion in one dimension in mechanics, what is a velocity? You know, velocity is a vector quantity and it is displacement by time. Correct? It is displacement by time. Correct? Now if I choose if DL and DE are the displacements happened by a machine in a same time. By a machine in a same time. In a same time or at a same time. In a same time t. Then what happens? How the velocity ratio will be? Let me check. Then velocity ratio is equals to, look here, if VE, that is velocity of effort, can be taken as displacement of effort. So that is dE by T divided by velocity ratio of load. Velocity means what? Displacement of effort. So displacement of load by time. Here time is same because I have told displacement happened by a machine in the same time. Means it will be both having the same time. Understand? Just see. Velocity means displacement by time. Instead of here velocity of effort, I have written as displacement of effort by time. Why? Velocity is nothing but displacement by time. Understand? Now here by cancelling T and D, we can write velocity ratio is equals to displacement of effort by displacement of loads. Correct? Even velocity ratio, not only velocity of effort by velocity of load, we can write as displacement of effort by displacement of load. So hence we can define velocity ratio as velocity ratio is the ratio of displacement of effort to the displacement of load. Displacement of effort to the displacement of load. You can define velocity ratio even in that definition or even in this definition. Know the both things. So I hope you are understanding better. Now when the same thing, what is the unit of velocity ratio? It is like same mechanical advantage, both displacement if you take both is meter and meter, right? Chances means what it gives. It is also a velocity ratio is also a ratio of two similar quantities. Ratio of two similar quantities. So it is not having any unit. So it has no unit. Understand? Here, see here velocity ratio I have written from this, or you can take first step as this, then apply it and get that. Understand? Because that is same. So velocity ratio is quantities and it has no unit. Very clarity I am telling you velocity ratio. Now you all know what we did in the case of mechanical advantage greater than 1 we have to find. When velocity ratio is greater than 1, when velocity ratio is less than 1, and when velocity ratio is equal to 1. You yourself can know this. When velocity ratio is greater than 1, when your effort should be more and load should be less. That is what we have to take. When displacement of effort is greater than displacement of load. When displacement of effort is greater than the displacement of load, or displacement of effort load is less than displacement of load is less than displacement of effort. So it has velocity ratio greater than 1. Means what do you mean by velocity ratio is greater than 1? It acts as a machine acts as a force multiplier. Very important. It is also understand only that you should not confuse between mechanical advantage means load in the numerator, effort will be in the denominator. Remember, but what do you mean by velocity ratio? Velocity ratio is effort, displacement of effort is in numerator, displacement of load is in the denominator. The only difference you need to make. Now, when machines act as a force multiplier, when actually velocity ratio is greater than 1, when displacement of effort is greater than displacement of load, or displacement of load is less than displacement of effort. Both are same. So then when velocity ratio is less than 1, when velocity ratio is less than 1, when displacement of load is greater than displacement of effort, or when displacement of effort is less than displacement of load, both are one and the same. Means it acts as a where velocity ratio will be less than 1. Machine acts as a speed multiplier. Gain means speed of the speed multiplier, or gain means speed. Speed multiplier or gain is speed. Then when velocity ratio is equals to 1, when displacement of effort is equal to displacement of load, that is changing direction of effort. Changing direction of effort. Understand? Then velocity ratio is equals to 1. This is what the concepts you need to understand. So I think for today's class is more than enough. 4 technical terms. We have 3 more: work input, work output, and efficiency. Those concepts we will see in our next class. And also we have relationship between velocity ratio, mechanical advantage, and efficiency. Very important for your examination also. We will see that in the very next class. See, understand the concept carefully. Write down. Ask the coach if you have any. 2 classes are very important to understand the next classes. Understand?